Yesterday, we have seen how to create a pod, which is the smallest deployment unit, deployable unit in Kubernetes. That we have seen through manifest files. Kubernetes manifest files are also called as definition files. And every Kubernetes definition file will consist of four top level elements. What are those? One is API version. Kind means the kind of object that we want to create, and metadata that will describe the kind of object that we are creating. That means naming that object and to give some additional information about that object. For that, we have metadata section, and the heart of the definition file is spec, where we will write the specification for the containers and other things. Now, so depending on the object, depending on the kind of object that we want to create, there is a corresponding API version for that. And some object may have the similar API version, something like this. Okay. Now we have seen how to create a pod using Kubernetes manifest file. So this is the API version for this kind of pod. Then this is the metadata. In metadata, we are specifying the name of the pod. Now, how to deploy this? And one thing here is spec. In spec, we have containers. Labels means we are labeling this pod called myNginx. Labeling means to identify this object with other things. Label means, for example, if you go to fruit market, there the apples will be labeled depending on the size, depending on the price and the quality. Based on that, they will be labeled. So label means just for identification purpose, we are giving some extra information to that particular pod. Here, I am giving this label. This is not mandatory to have the labels, but this is some additional data that you want to keep so that you will identify this pod more clearly. So that's why. So in these labels, we are having env. So this is also user defined one also. You can keep anything here. I'm something like identifying this as this pod belongs to the dev environment, something like that. Then in spec, we have the containers specification, and the containers is an array. Array of the elements of the array will be represented using hyphen. You can give any name to the container, and if you observe, this is the pod name. This is the container name which is running inside the pod, and this name can be same. There is no issue. And what is the image that you want to create the container? You want to use to create the container. Okay, so this is the image that we want to use. Now let's apply this kubectl. First, let me confirm whether all of the nodes are ready or not. Yeah, they are ready in state. Now let's apply this. The pod name is, the file name is this one. The pod got created, get pods. It's being created, the container is being created. Now the container is running. Then I want to create another pod. Let's copy the same thing. Now let's name it as demo pod, or let's say pod 2. Here I'm naming this as 2, or else what I will do is, yeah, I'm naming. If you try to create this, let's see what will happen. This is another file. The same file is there. Now what I will do is, I will apply this file pod 2. Here what it will tell, see, unchanged. Because the files may be different, but the definition inside the file is same. So when we are trying to apply that, we are trying to apply the same configuration which is already existing in the cluster. When we are trying to apply that, what it is saying, it is unchanged because nothing is changed in the definition. So that's the thing. Now, what I will do is I will try to create, I'm just keeping here 2. It means what? Now another pod will be created. Now that pod name is this one. The container name can be same, okay, as that of the earlier one. But where they are distinguished, the first one and this pod, they are distinguished by the name of the pod. And internally we can have any name for the container, and this container might be used in the other other pod also, but that doesn't make any difference. But here the pod makes the difference. Now if we try to apply the same thing, what will happen? The pod will be created with this name. See, it is created. If I apply the same file, what will happen? It will tell something like unchanged because this pod has been created and there are no changes made to the file. So that's why the pod is unchanged. Now, if we see kubectl get pods, we should have 2 pods running. One is this one, another one is this one. Of course, the container names may be same, but the containers are not the smallest deployable units in the Kubernetes. Pods are the smallest deployable units in the Kubernetes. So that means a pod name should be unique in the cluster. You can't have the same pod name in the same namespace of the cluster. Of course, within different namespaces, across namespaces, the pod name can be same, but within the same namespace, the pod should be uniquely named. And what is namespace? You will understand soon. Then, so that is how we will create this. These things we have seen. So kubectl run ready. So then now let's run dry run. Let's run dry run command. So dry run means what will happen is this command we know. Okay. So this command we know kubectl run redis. This means what? We want to run a pod and we want to name that pod as what? Redis. Now what's the image that we want to use? I want to use Redis image. And where this image is there by default, in Docker Hub, it will be there. It will be there in the Docker Hub. Then dry run means what? Dry run equals to client. So it means this pod won't be created. Instead, it will generate the YAML file for the corresponding pod. Okay, and that YAML file, which we are getting that in the YAML format, the output we are getting in the YAML format, I'm redirecting to some file name called as pod.yaml. Now let's look what will happen. So here, let's name this as pod3. Okay, so what we are trying to do, we are trying to create a pod using dry run. That means it won't be deployed. Instead, when it is deployed, what configuration, that configuration file will be redirected to pod3.yaml. So we are using dry run, means this pod won't be created. Instead, the file will be generated and that file we are saving into pod3. Now let's hit enter. See what happened here. pod3.yaml has been created. See what is happening here. So this is very useful command, very useful command. So we don't need to write the manifest file. With this simple command, we are able to generate this. So if you see 4 top level elements, one is API version, kind, metadata, spec, and there's some unnecessary details. If you want to delete, you can remove them. Now let's also remove labels. Now So this is the image. And one thing, friends, you can give image first and the name second, or also give the name here. You can give the image inside as well. There is no problem in that. But it's good practice to have name here. Not good practice. You will be understanding the different name, different containers with their names if you have the multi-container pod. Now, so these resources, you will understand these things later. I'm also deleting these things. Restart policy also we are deleting. So I'm keeping only this thing. So corresponding to this, what happened? This file got generated. Now let's check whether this pod has been created or not. That won't be created because we have used the dry run. See, that pod is not there. Now you can use this file to create that Redis pod. How to use that? kubectl apply yeah pod3.yaml. So from this configuration, Redis pod is created. So this is how you can generate the YAML files in Kubernetes. Very simple, right? You don't need to struggle about the file writing, but it's good to know that. Okay, so the Redis pod is running. If you want to delete that, you can delete pod and you can give the pod name, or else also you can use the file. So if you use this file name, whatever the objects that are created using that file will be deleted. So why I'm saying the objects that are created means in the same YAML file, you can write multiple definitions. In that case, if you use kubectl delete f and the file name, all the objects that are created in this using this file will be deleted. That also we will see later. This is for edit anything. You can use the edit command we have seen yesterday. It will generate the current YAML file or current configuration. kubectl edit pod. Let's edit my nginx pod. If we apply this, see what will happen. So this is the current configuration of the pod. Okay, so when it was created, so all the default things that will be given by the Kubernetes. It will give all the details. See, if you see, is this the definition that we have used to create the pod? No, some additional information has been added because this is the running configuration of the pod which we have created. So what is our pod definition? This is our pod definition. But when it is applied and deployed, so the Kubernetes is saving its state like this. Okay, so this is the thing. So once we close this file, now it says edit cancelled, no changes were made because we did not touch it. And we don't usually do changes using that method. We will always change the change the things in the repos itself by committing the changes to the repositories for GitHub or Bitbucket or whatever the things that you are using. Then after that, now what I said, if you use the Kubernetes object called pod, you can't have multiple replicas for this image. You can't have multiple replicas for this image because this is a lower level object in Kubernetes. In Kubernetes, we have some higher level objects which will manage the pods. Yesterday, we have seen diagrammatically, we have a deployment. As a part of that deployment, initially we have created a single pod. Later, we have scaled it up and scaled it down. So yesterday we have seen the object called deployment. Anyway, that also we will see again in the definition of files. But let's come from this replication controller. This replication controller is another Kubernetes object which will allow us to create multiple replicas for the same pod or for the same application. So what is the definition? So now let's copy this definition and I'm naming that as RC application controller. I'm naming that as RC. Simply it is up to you to name the file. Now let's observe this. Here again, API version is there, metadata is there, kind is there, spec is there. Now, here the name of the replication controller I'm giving as my app RC. It's up to you. You can give C1, C2, RC1, RC2, anything you can give. So these are the labels of the replication controller. That means I'm giving some additional information to the replication controller called my app RC. What are the labels I'm giving? You can give as many labels as you want. Here we are giving two labels. One is app equals to my app type equals to front end. Of course, this is column. Just meaningfully, I'm reading it as equals. App equals to my app type equals to front end. With these labels, we can say that this replication controller called my app RC, it's a front end and it's an my application, something like, or you can give something like env equals to dev or prod or QE, something like, or staging or UAT. So some additional information we are giving. So now let's come to spec. Now, what I will do is, first, I want to write definition of the pod. What I will do is, this is the pod definition. Okay, any doubt in this? We know this is the pod definition. This is the name of the pod that I want to give. These are the labels that I want to give to the pod. And this is what spec. In spec, we have containers, and the name of the containers is this one. Of course, we will be having other points also in this that we will learn slowly. Okay, so this is our usual pod definition, right? Now, and with this, we can't have multiple pods for the same application. But what I want to have multiple replicas which will run the same Nginx application, so that even if one replica is terminated or down, or if something happens to that, then my application should be highly available. For that purpose, we need to have multiple replicas for that. For that, we have some higher level object called replication controller. What is its definition? This is the definition of the replication controller. So first, this is the API version, this is the kind, metadata, and this is the name, and this is a spec. In spec, in pod, we have containers, but in replication controller, we have what? Template. Template means in template, we will give the definition of the pod for which we want to have multiple replicas. Got it? So replication controller we use to create multiple replicas of the same pod. And what is the pod definition? That pod definition will be written in the template. Got my point? So What part of the pod definition? So this is the thing. What I'm doing? I'm just bringing that to here. See, something like this. So this becomes the replication controller, right? So in spec, in template, what were we giving? We are giving the blueprint or the template of the pod for which we want to have multiple replicas. How many replicas we want to have? That property should be written in the spec. That should be written in the spec. That should be written in the spec means that should be at the equal level that of the template. Okay, so now it should be equally placed. It should be equally placed here. What is that? The replicas thing. Or else what we can do is we can mention anywhere, friends, in YAML. There is no order, right? So we can mention that replicas as 3. Now, a replication controller will be created and it will be named as my app RC, and it will contain this pod. And how many pods will be there? 3 pods will be there. That means 3 replicas which will run the same application. And these are the labels of the replication controller, and these are the labels of the pod. Now, let's deploy this. What I will do is, this is the pod and the label I am giving as something like 0 or else let's name it as P, stands for pod, and I'm naming it as P, front end P. So this is also P. I'm giving something like this. Now let's deploy this and see what will happen. So what I have done to make you clearly understand, I'm giving the labels for pod differently, and means we are giving the labels for the replication controller and pod differently. So these labels are these one, and these are different labels we are giving. So now let's try to deploy this and see. RC. What happened? My app RC got created. If you want to check it, kubectl get RC in short, or you can use kubectl get replication controller. This is the full one, and simply we can call it as RC. Now you understood that, right? So tomorrow, if in some definition files if already existing, and if you are going through them, and if you see, they may be using the same labels for the replication controller, this one, okay, there is no problem in that. But so these labels are different than the top. There is no condition that the pod label should be exactly same as that of the replication controller labels. So this is, so with this what we have done, we have created a replication controller, and this replication controller is having 3 pods. 1, 2, 3 pods, and these 3 pods may be running on different node. Now let's get them. kubectl get pods. Let's get wide. We'll get wide information. See how the pods are named. How the pods are named. The pods are named. How they were named? See, this is the replication controller name. Replication controller name. Pod name is my pod, but Is it what here it is showing? No. The pod name is named something like the replication controller name and some random hashtag, which is in alphanumeric, separated by hyphen. Okay, this is how the pods are named. Now let's go and see, uh, describe the pod. And if you see here, these three pods are part of that replication controller, and two pods are running on one node, and the pod is running on another node. So describe pod. Let's describe one of these pod. One of these pods. Describe that. If you see here, so this is the pod name, and these are the labels for that. So like that, it is created. Now, this is just a template that is used by the replication controller to create the labels. Now, what will happen? Replication controller will always ensure that the desired number of pods are up and running. So our desired number is how much? 3. So now let me delete these existing ones so that there is no confusion. Delete pods, my nginx and my nginx to kubectl get pods. So let me delete one pod, delete pod. Let's delete this B2 pod. Now see what will happen. So in its place, another pod has been created. So that means replication controller ensure that always desired number of pods are up and running. If you remove all these three pods, these three pods will be immediately created. That is, somebody wants to ask something, they have unmuted.
Yeah, Lakshman, I have one query. Like yesterday, we have seen the same scenario in deployment also. Okay, like where
Okay,
we
we
can
will see
scale up.
that deployment as well. Okay.
So, what's the difference? Like, I want to know what's the difference. Like, we can achieve the same thing, like scale up and scale down in deployment also, and we are achieving the same thing
What
typically.
will happen is
Mm.
in deployment, we have the concept of rolling updates
Okay, okay,
without getting any downtime. We can update the application, but that facility is not there in the replication controller. Okay, so this is matured from replication controller to deployment. We can see that some maturity has been come. Here we will be having other options. So in the
okay,
deployment also, if you create three replicas, if you delete any one of the replicas or all the replicas, immediately after their deletion, in their place, pods will be created so that always desired number of pods are up and running. Okay, that is also there in the deployment. But in deployment, we have the concept of rolling update. And in Kubernetes, we will be using the deployment only mostly. Okay, and okay, you will see that. You will see that.
okay.
Now, this is the replication controller, and these are to describe to get them to create, and we can see that. Then a replica set, and between replication controller and replica deployment, we have another object called replica set. And here for replication controller, the API version is V1. Here the API version is app/v1. Now, here kind is replica set, and so the same thing, the definition is exactly same as that of the replication controller. Only some change is there. I will tell you that. And before that, what I will do is kubectl delete replication controller. I'm just deleting this one. Now, what I will do is Okay, this is now I'm trying to create this pod now. I'm trying to create this pod. kubectl apply here. kubectl get pods. See, the pod has been created, and this is the same definition that we are using in the replication controller. Okay, nothing changed, everything is the same. Now what I will do is I'm going to deploy this replication controller as well. Get pods. See how many pods created? Only 2 pods created, but we have mentioned the replicas as 3, right? But why only 2 created? Because in replication controller, whatever the thing that we are giving in the template, and if already a pod is created with the same template, that pod will also be taken into consideration in this number, in this replica count. So that means the pod, the earlier pod was created using the same definition. Okay, the pod, see the same definition we have used, and the pod name was now taken as this one because that is not a part of the replication controller, but that was created using the same definition as that of the definition that we are using in the replication controller. So in this case, this replication controller will also take the pod will also take the pod which is created using this exactly this kind of definition into consideration of these 3 pods. So that's why only 2 are created, and because this was already created, it is also taken into consideration in this 3. This is one thing. Now let's come to replica set. The replica set definition is almost to same as that of the replication controller, but API version changes.
One query.
App/v1. Now let's delete this replication controller which is already created. So I have deleted this. Now I'm creating another file, or else let's do what? I'm just trying to copy these things. Now let's name it as replica set.yaml. So here the replica set, the kind is replica set. API version is app/v1, and here we will be having another property called selector. So selector. With this, what will happen is it will create 3 replicas from this definition. I think P is missing here, which we have used. Something P should be here. That's fine. So from this, P should be there. Okay. So from this definition, what will happen? 3 replicas will be created. Now, let's do one thing, get pods. I hope that the single pod is already there, but it's not there because when we delete the replication controller, that pod will also be deleted because that became the part of the replication controller once the replication controller was created. So that's why this pod also deleted. Now what I will do is I will deploy this pod. Now, when we deploy replication controller with 3 replicas, what will happen? Only 2 will be created because already 1 is created from the same definition that we have seen. Now let's come to replica set. The definition is almost the same. API version we have changed from v1 to app/v1, and here we should have replica set, and in addition we have added this property here. Now let's see what will happen if we apply this file. No object asked to apply. This replicas, okay, got it. Yes should be capital, because many times I read these definition files, right? So that's why I remember that here it should be yes. So somewhere it is showing the replica set my app RC is invalid because in spec and in template and in metadata and in labels invalid value as template labels. They are not matching the template labels. Okay, so now I will tell you. So in match labels, what I will give is I'm giving P here. Now what happened? The replica set has been created. Now let's come to this point. In selector, what we have mentioned, match labels type B. That means this replica set will create the replicas from this definition, and it will create only if this label is matched. That means in match labels, we are giving this, we are giving what? Labels of the pod definition we are giving here. We are giving here. And now what will happen is pods will be created from this definition, and the pod label, any one of the label must be matched here. And what is it? Now let's see why it was put that condition. If you see here, again, how many pods were created? 3 pods were created. We wanted to have 3, but again 2 were created because this is also taken into consideration. Now, what I will do is I will delete this replica set. Please observe what will happen. Replica my app RC. That means this pod will also be deleted because that became the part of the replica set once when it was created. Now what I will do is I will change its labels. I will change its labels. And let's create. Okay, that pod, the pod gets created. Now let's come here. See, the type equals to front end here. There is no A appended to these labels. But here we want to select the pods which are having labels like this. One of the labels like this. Now kubectl apply F this replica set. If we do this, what will happen? Observe. See, three pods were created. This was not taken into consideration because we want to create three replicas, and those three replicas will be created and will be selected when the labels are matched, which are mentioned here. And for this, the labels were different, even though the definition is same. The labels made the difference. Anyway, the pod name itself is different. And so then what's the thing with these labels? Now what I will do is, now this time, let's do another thing. Now with this you will get some clarity. kubectl delete replica set. My of RC is the replica set. Now let's do one thing. We are having a pod. Now let's name this as something like pod 1. And let's have some label which matches here, which matches here. But everything is different. Only the labels we are creating that we are using in this particular replica set. Okay. So now anything, let's name it as a C1. Okay. In order to avoid confusion. Now let's create this file. First, let's see any pod is running. I forgot this pod. Let's delete it. Let's create that pod now. That pod will be created for sure. Now, see, the definition is totally different than that of this one. Okay, so we are using totally different names, but we kept a label which we are trying to match in the replica set. Now see what will happen. kubectl get pods. We use this, what happened? See, okay. Single pod we are taking, right? Single this one. Let me do one thing. Delete pod. Delete replica set. My RC. It should match all the labels, friends. I'm confused. No, it don't need to match all the labels. Type content P. See, here it should be preference. That's why it did not work. Nobody is telling that to me. That's fine. Now, kubectl delete pod 1. I'm deleting that. kubectl apply f demo file. So the same labels we are trying to match here. Now let's see what will happen. kubectl apply f replica set. kubectl get pods now. Get pods. What happened? Only two were created because this replica set took into consideration the pod which is running, but with the same label that we are trying to match here. Okay, so that's the difference, small difference. So that means additionally we can bring the other pods into this replica set cover by using the this one match labels. Anyway, we are not going to use this much in the real time. Okay, just for understand. Tomorrow you may get doubt what's the difference between replication control and replica set. So that's what we are doing here. So in replication controller, we don't match the labels. So the parts will be created from this definition, and if the same labels are there for the parts which are created using the same file, same definition, that will also be coming into this cover. In replica set, we are explicitly mentioning the label that should be matched when we want to have the count of 3 replicas. Okay, so that's the thing. Now we can scale the replicas of the replica set and see what will happen. Now, okay, so now we have to understand this command, replace command. Now let's edit the file and set replicas to 5. So three are running. Now let's keep as 5. What we can do, we can apply this kubectl apply F. Observe what will happen. Because already 3 were running, 2 more will be created. See, just now 2 more are created, totaling to 5. Totaling to 5. 3, 4, 5. Now, I will use 6 here or 7 here, and I will use replace command here. Sorry. See, stated got replaced. Now see what happened. 1, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. 3 were basically running. 1, 2, 3 in the original file. So later what happened? Later what happened? We wanted to scale it up to 7. In this case, something strange I'm seeing. Now let's keep 2. Let's keep this as 2 and let's use what is happening because we don't use this often. So that's the reason I'm a little bit confused in this. Only the original 2 were being there. So the parts that are created, the recent updation are being terminated. Anyway, friends, this is what happening. But what's the purpose of running that? Uh, I'm not familiar much about that because I don't use this in the real time. Of course, you too don't use this in the real time. Okay, I will understand this functionality and I will tell you later. Okay, and that is not much important, but I too need to understand, right? So I will tell you that what is happening when we are using replace. Now let's understand kubectl replace. the difference between apply and replace is similar to the difference between apply and create. We know the difference between apply and create, right? What's the difference? If the object is not created initially, we can directly use the create command. But if the object is already created, if you want to make any change, then you can use the apply command when we change the configuration file. And if you don't want to use the create in the initial stage, then you can use directly apply. That's fine. That difference we know. The create replace use the imperative approach while apply uses the declarative approach. If you use to create the resource, then use replace to update it. Okay, got it, got it. But what's the use of doing that? OCTL, delete, replica set, my app RC. Now, what we are trying to do is whether using apply or using create, whether using apply or using create, what we can do is we can create this object. Okay, kubectl create f replica set. Now, when we are trying to make some changes, and if you want these changes to be reflected, now what we need to do is we have to use apply. Okay, in that case, what will happen? Already 3 were running and 2 more will be added, totaling to 5. But let's use replace. In this also same thing will happen, right? Then what's the difference? Same thing will happen. Okay, got it, friends. So when we use replace after using create, what is happening is everything is being replaced. All the objects that are created will be replaced. No, friends, that's not happening. This is something bad. I can't conclude that by reading this one. I have to observe what is happening. We use to create this, then use replace to update it. Yes, that we are doing right. Okay. Now let's go in turn. kubectl delete f replica set. Let's use apply to create the resources. And let's have only 3 replicas set. Now 3 replicas. kubectl apply replica set. kubectl get was 3 replicas will be created. Now let's try to keep it as 5. Let's use, this is not something like trial and like that. So here, just to understand that one, I'm doing this. Of course, we are not going to use that in other pipelines. So according to the statements that is given, same thing is happening, but I don't know why it is. And what is its exact requirement if somebody wants to use it? I will get to know that, friends. Clearly have to study about that. Okay. So that's the difference between the replica set and replication controller, where in replica set we will select the parts by matching the labels. Okay, that is fine. If you want to scale it up, then you can use kubectl scale and scale replica set, the replica set name, and the number of replicas you want. And it is better to keep these things here and the replicas at the end so that it is clear. So now let's use 3 here first initially. Now let's update it. kubectl scale replica set. What's the replica set name? My app RC. How many replicas you want to create? Replicas equals to, let's keep 7. Now kubectl get pods. What will happen? 4 more will be created, totaling to 7. Now 7 are running. Now kubectl describe replica set, my app replica set. Now, if you see here, I expected that the events will be clear. Okay, yeah, that's not my interest. Now, what I'm trying to do is, let's give different image here. Now, let's edit replica set. My app RC is the replica set name. Now, what I'm trying to do is, I'm trying to update the image here. What image I want to use? Now let's use some different image. Let's use Nginx image with a different version. So Nginx, this is there, right? So now let's use this image. Bitnami Nginx, let's use. So we are trying to modify the image. You see what happened? This got edited. Now let's okay, pods are running, that's fine. There is no impact on the pods. kubectl describe replica set. Was the status that we got here? Okay, that is edited, fine. Now what's the image that is running, that is being used in this? Okay, that's also fine. But why we are not getting the events clearly here? Let's go and check the events of the pod. kubectl describe pod. Let's go and describe one of pod events. Why that's not updated? Let's use different image altogether. Let's use Tomcat image here. kubectl describe replica set via parse. Okay, that's fine. Okay, so image is updated. But in this, what will happen is, when we are updating the image, that is not the rolling update. The application will face downtime. In order to overcome that, we have the another Kubernetes object called deployment, which is very important, and that is the object that we are going to use in the real time. And what is rolling update? What is the recreate? All those things tomorrow we will see. That's it for today, friends. Please practice the things that we have discussed today. Otherwise, we will be confused. Okay. If you have any questions, you can ask me. Otherwise, we can wind up this session.
I have one query now, like like you are while we're deleting replica set, so the existing pod is also deleting, like which will be taken consider. Can we avoid
Yes.
such cases? Is there any way we can avoid?
Hmm.
Because let's suppose we have
For
multiple pods.
example,
Yeah.
yeah, if you want to do that, we have to change the labels of that particular pod.
Okay. Then only
Okay.
we can.
So if you change the labels, then that won't be coming into that replica set. And because in replica set we want to have three, one more replica will be created for that. And when we uh, delete that replica set, only those pods which are part of that replica set will be deleted, and that pod will be there. Got it?
Okay. Yeah, got it. Like
Okay.
without label change, we cannot do it. Okay.
Yes, yes. So why it is coming on to coming under this replica set is because we are matching the labels.
And let's suppose we haven't given any label, then in this case it will not taken as consideration, right?
Yeah. So if the labels are not matched, then that won't be considered in this.
Okay, fine.
Okay, friends. Let's meet on Monday. Thank you.
Okay.